Hi everyone, today we are going to start the last section of chapter 5, which is 5.6, Indirect Proofs. We're going to start off with the hinge theorem. If two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, this means that the third side of the first is longer than the third side of the second. So what does that mean? Well, we look at this example here. We see that VW is congruent to RS, and I see that because of these tick marks. I also see that VX is congruent to RT, and I see this because of this tick mark. I also see that angle R is greater than this angle R, meaning that this segment XW is going to be larger than this segment ST, which is written here. That is the hinge theorem. Now there's also a converse of the hinge theorem. If two sides of one triangle are congruent to two sides of another triangle, and the third side of the first is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. So now we're just talking about side lengths. If I know that this is congruent to this segment is congruent to this segment, I notice that my third sides are not congruent. I have 12 and 9. That means that angle C is larger than angle F because AB is greater than DE. Direct reasoning. Reasons with the given information using detachment and transitivity and concluding with the proof. These are the types of proofs that we've been working with, the ones that you love. So direct proofs are the proofs that we have been writing in the past. Indirect reasoning examines and rules out all the possibilities other than one thought to be true. This is the method used in solving logical puzzles. We worked a lot with this at the beginning of the school year. So we want to show that 5 times the quantity 2x plus 3 equals 10 times the quantity x plus 1 is never true. All right, well, let's simplify these. So if I have 5 times the quantity 2x plus 3 is equal to 10 times x plus 1, first thing I need to do is distribute inside my parentheses. So this gives me 10x plus 15. I need to do the same thing on this side. So this becomes 10x plus 10. Now, what do you notice about this equation? What do they have in common? Well, I see that I have a 10x and a 10x on both sides of the equal sign. What happens in this case? Well, these would cancel out, and I'm left with 15 is equal to 10. Is that a true statement? No, it's not. So we just proved that this could never happen, that 5 times the quantity 2x plus 3 is never equal to 10 times the quantity x plus 1. Let's try this again. We want to show that 2x plus 6 equal to 2 times the quantity x plus 3 is always true. So we want to do a very similar step. So let's set these equal to each other and solve. So 2x plus 6 is equal to 2x plus 3, that quantity. All right, well, I need to distribute. So 2x plus 6 is equal to 2x plus 6. All right, well, what do we notice here? I have the same equation on both sides of the equal sign. So this has to always be true because they are the same equation. And if I wanted to solve for x here, I have 2x and 2x, so those would cancel. I also have a 6 and a 6. These would cancel, meaning that 0 is equal to 0. Anytime this happens, we know that those equations were the same, and they are always true. Contradictory statements, 2 statements that cannot be true at the same time. So let's look at this statement. So Angle V is an acute angle, and we are also told that angle V is a right angle. Are these contradictory statements? Yes, they are, because an angle cannot be both right and acute, so these statements are contradictory. Let's try this again. Are the given statements contradictory? For part A, angle B is a right angle and angle B is an obtuse angle. Is this contradictory? Yes or no? Yes, it is. You cannot have both a right and obtuse angle at the same time. So this cannot happen. They are contradictory. Let's look at B. Triangle ABC is isosceles and triangle ABC is equilateral. Are these contradictory? Now this is a trick question. The answer here is actually no, because technically an isosceles triangle is a triangle that has two congruent sides. An equilateral has three. Well, isosceles triangle, or I should say an equilateral triangle, is technically an isosceles triangle. And I know that's kind of hard to think about. I would never give you a question like this on a quiz or test, but it could be on an air test. So an equilateral triangle is technically an isosceles triangle because it does have two congruent sides. Part C, x is an odd number and x is divisible by 2. Is this contradictory? Yes, it is. These could not happen at the same time. We know that all not odd numbers are not divisible by 2, so this could never happen. And finally, part D, x is an even number and x is greater than 10. Are these two statements contradictory? No. There are a lot of even numbers that are greater than 10, so this could happen.